One of the best sci-fi shows out there is, of course, The Expanse, the TV show whose main premise revolves around humanity conquering the solar system, and specifically following various plots across the solar system, with various human factions trying to establish themselves while living on various planets and various moons. And one of the main factions in the story are the Belters, humans who were born and raised in the asteroid belt, and humans whose body was developed in low-gravity conditions, and who were also sort of represented as an underclass in this entire society. But they provided vital resources, including ice and minerals, that kept both Earth and Mars alive. In other words, Belters were the mining class. They were mining the asteroids. And that's essentially what we're going to be discussing today. We're going to discuss the idea behind asteroid mining, and if this really cool science fiction concept can actually become reality sometimes in the future, especially because several companies have been talking about this for the past few years. Now, just so that we're clear, this is obviously not sponsored, but we have companies like Carmen, Astra, and Astroforge that represent some of these first startups whose goal is to basically find a way to mine asteroids sometimes in the future. And actually this one we're going to be discussing a little bit more, because they are the ones that came the closest so far. And so, hello info person, this is Anton. Let's discuss the concept of asteroid mining and how feasible it is, according to some of the most recent studies you can find in the description. And in case you're not going to be watching the whole video, the answer is, it's not feasible. It's unlikely to happen, or at least unlikely to happen for another few decades. And that's despite the fact that the idea of asteroid mining has actually been trending a few times in the past. As a matter of fact, after SpaceX started launching reusable rockets, we suddenly had a lot of different headlines talking about these super expensive asteroids that we could now maybe start mining in order to return some of these resources back to Earth. And one of the most commonly talked about asteroids is 16 Psyche, the asteroid that NASA is going to be visiting very soon, and it essentially contains so many metals that in theory it can provide resources for up to a million years. But we're not going to be discussing hypotheticals in this video, because this video is going to be grounded in reality. And the hard truth in this case is that, and the technology is just not ready yet. Because now we've officially moved past the hype era into actual scientific assessment of how realistic asteroid mining actually is. And so let's talk about some of the technological hurdles, some of the recent attempts from at least one company, and a major pioneering study from 2025 that essentially changes our understanding of what sort of asteroids we should even look at, because not all of them are made equal. And this idea is obviously not new. Here's a really early picture of a concept where NASA thought that maybe we can mine these asteroids by first moving them closer to Earth using a kind of a space tether. And that's until we visited some of these asteroids and discovered that most of them do not seem to be hard rock. They're essentially just a rubble collection, which means that any kind of a tether is just going to go through them, and so none of this would ever work. But nevertheless, this concept is still exciting. And that's because of what we know about various metals and various materials on the surface of the planet, and what we've already discovered about various asteroids. And so here, if we look at the history of our own planet, we know that most of the heavier metals very likely sunk into the planet a long time ago. And so things like gold, platinum, and nickel are mostly stuck inside the core of the planet and not on the outside. But we still find a lot of precious metals on the surface, because a lot of them were eventually delivered to the surface by various asteroids. And so a lot of the stuff we find inside the crust of Earth technically came from outer space, from a variety of these really ancient rocks. And so in essence, asteroids are kind of like leftover construction material from the formation of the solar system. And quite a few of them do contain a lot of precious materials. As a matter of fact, some of them contain concentrations of platinum group metals that are dramatically higher than anything we find on the surface of Earth. But obviously beyond just wealth, by mining asteroids, we can also take all of these dirty industries into outer space, and so instead of polluting the surface of the planet, we can do all of this outside, reducing the environmental impact. But the thing is, even though these ideas on paper do sound kind of simple, the reality is very different. And that's because when it comes to technology, it's still actually in its infancy. And here you just have to look at the facts. As of 2026, only approximately 126 grams of stuff, asteroid stuff, has ever been successfully returned to planet Earth from various interplanetary missions. And in theory, this actually cost over $1 billion in government investments. Here we're talking about the NASA's OSIRIS-REx mission and the Japanese Hayabusa 2. And well, nothing highlights this more than some of the reports from Astroforge, the company that makes this very bold claim. We mine asteroids. I mean, it should be we will mine, or we're going to mine, or we might mine, but I guess they're pretty confident in their abilities. And so let's examine this startup. Back in April of 2023, they launched their first satellite referred to as Broker 1, the mission whose job was to test a refinery system in low Earth orbit. In other words, this was a test of technology that one day could maybe be used to mine asteroids. But here things went wrong almost immediately. First, they struggled to find the satellite for 20 days because it was one of 50 satellites launched by SpaceX on a rideshare launch. Then, once it was found, they discovered that the magnetic field from the refinery system seems to have prevented solar panels from deploying correctly, eventually causing the satellite to wobble and making communication impossible. So this was a failure. But they didn't stop. In February of 2025, they launched the second mission, Odin. And once again, this was declared lost once it encountered ground station and communication failures. In other words, even though they learned from their first mistake, they now had new issues with the second satellite failing again. And even though they're going to be launching a third mission, referred to as Vestry, sometimes in 2026, in essence, these setbacks are a very serious reminder that even with reusable rockets, and even with technology we know works on Earth, the complexity of operating something very similar in space, especially when it comes to specialized mining equipment, seems to be quite immense. It seems to be so challenging that so far no one succeeded. And this applies to pretty much every startup and every single attempt in the last few decades. At the moment, except for the OSIRIS-REx and Hayabusa 2 mission, nobody has found any way to extract anything from any asteroid. It really is pretty difficult. And though in theory it might be a little bit easier on a larger object like Psyche, at the moment we still have no technology and no mining equipment that can be successfully used in outer space. Which actually brings us to this very significant scientific update from 2025. Here, a team led by Dr. Joseph Trigo Rodriguez from the Institute of Space Sciences provides a reality check for the entire space mining industry, and specifically by analyzing different types of asteroids and discovering that most of them may not be mineable at all. In essence, they analyzed carbonaceous contract meteorites, which seem to make up about 75% of all known asteroids, discovering something very important about them. They seem to be what's known as undifferentiated asteroids, or basically bodies that are too messy and heterogeneous for any current technology to be able to use. And so these primitive original pieces of the solar system seem to be not viable for any kind of a mining extraction. And though for scientists these are very valuable, providing information on the chemical composition and the evolutionary history of the solar system, when it comes to mining, that's a different story. They essentially discovered that most of them seem to have relatively small abundances of precious elements, and seem to contain a large mixture of a lot of different materials, which would be very difficult to isolate from one another. However, researchers also identified a much better target. Some asteroids that seem to show olivine and spinel bands do contain higher concentration of rare earth elements, which of course are very important in modern electronics. And so in other words, this particular study tries to classify various asteroids by discovering what sort of elements may be present in some types of asteroids, and by creating a kind of a shopping list of which specific asteroids should be targeted if we ever decide to mine one. And here it turns out the list is actually not that long. When it comes to these rare earth elements, only certain types of meteorites and asteroids contain the right components. But even here extracting them is much more challenging than just finding a way to extract them on planet Earth. And so instead, the focus of the study then switches to something else that is a kind of important resource: water. And specifically because certain carbonaceous asteroids contain a lot of extractable water that can then be used as rocket fuel in various space missions. And extracting water apparently is way more viable than trying to extract any metal or rare earths. And here it makes financial sense as well. Launching various rockets from Earth is super expensive, especially heavy rockets whose destination might be Moon or even Mars. And so theoretically, if we could create some kind of a refueling station by using asteroid water, this could actually dramatically reduce the cost of every mission and make deep space exploration a lot more achievable and self-sufficient. But that's of course in theory. In practice, there are still a lot of challenges. And the three main ones are mentioned in the study. First, microgravity. And so in space, there's almost no gravity to hold a drill down. And so if you do drill into something, first of all, you'll just push yourself away. But second of all, the drill is going to create a massive cloud of very sticky dust that can pretty much clog everything and can also damage the equipment that's around the asteroid. And so unlike Earth, where dust just falls to the ground, here, if we create space dust around an asteroid, it can possibly destroy all of the equipment used for mining. Second, this mining procedure can create a lot of additional debris, which may then even return to planet Earth. And so here this might actually increase the chance for the Kessler syndrome depending on where the asteroid is located. And so if we end up mining some kind of a near-Earth asteroid, it can dramatically increase the Kessler syndrome and could then even create a chain reaction, destroying a lot of satellites around the planet. With the third reason being legality, or basically legal uncertainty. The Outer Space Treaty of 1967, which you can see being signed right here, states that no nation can own a celestial body, and though we're allowed to use it for resources, we cannot claim an asteroid or a moon. And on top of this, the Moon Agreement requires sharing these resources with the international community, making this whole thing a little bit more gray when it comes to legality. And what makes it even more uncertain is the fact that US, China, and Russia never ratified the Moon Agreement, even though technically they were the first to propose it. And so there are still definitely quite a lot of different limitations and hurdles that we just do not know how to cross. And so, what are my final thoughts here? Well, technically asteroid mining is slowly becoming a reality, or at least the companies are trying something here and there, and it's no longer just science fiction hype. But as we've discovered in the last few years, it is very challenging, which means that we're not going to be getting belters from the Expanse anytime soon. But as this recent study also discovers, we may need to be very specific about our targets, and we may need to first focus on things like water, and not precious metals and rare earths. But we're definitely going to be hearing more about all of this, especially as the Chinese Tianwen-2 mission gets a little bit closer to its destination, and that's because this mission plans to return another sample from a near-Earth asteroid in the next couple of years. Intriguingly, it's visiting one of the most exciting objects discovered in the last decade, the quasi-moon of Earth referred to as 2016 HO3, also known as Kamoa Alewa, which we now believe might be a chunk of the moon released by an asteroid collision. And so that particular mission is going to be returning samples to Earth sometimes close to 2028. But for now, asteroid mining is just going to remain an extremely complex puzzle. We have some pieces figured out, but in order to build the entire frame, it will probably take us a few decades. Anyways, we'll definitely come back and discuss this idea in some of the future videos, and until then, check out previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.